This question is from GATE 2019 Mechanical Engineering paper set 2, question number 50. The figure shows the pouring arrangement for casting of a metal block. Frictional losses are negligible. The acceleration due to gravity is 9.81 meter per second square. The time in seconds, rounded off to 2 decimal places, to fill up the mold cavity of size 40 centimeter by 30 centimeter by 15 centimeter is dash. Let's find out. Let's first name some points here. So let this point, where it is given that at this point there is atmospheric pressure, let this point be point A. This one, the center point of this casting mold, let this point be C, and this one be point B. We can write pressure at point A is equal to pressure at point B is equal to pressure at point C, which is nothing but atmospheric pressure. Also, velocity from point B to point C is not going to change because the cross section is uniform throughout. So we have velocity at point B will be equal to velocity at point C. We are using small v to denote velocity, and capital V we will use to denote the volume of this whole mold. So volume of mold is equal to, it's given as 40 by 30 by 15. So finding this out, it is 18,000 centimeter cube, because these values are given in centimeters. Now we are to find out the time taken for the metal to flow. So for that we have to use the definition of rate of metal flow or rate of flow of metal, which is volume of metal flowing divided by the time taken for the metal to flow. And by rearranging this, we will have TF will be equal to Vm upon, Vm is nothing but volume of the mold, of course, rate of flow of metal. Rate of flow of metal can be found out using the velocity, and this we are going to take the velocity at point C. So velocity at C into the cross-sectional area that the metal is crossing, or to which the flow direction is perpendicular. So we will have this area, and this area, of course, we have to take the area at point B because metal is entering through this pipe in order to enter to the casting mold. Now we need to find out this velocity at point C. To find this, we will use Bernoulli's equation. So according to Bernoulli's equation, we have sum of pressure head, velocity head, and height from the datum will be equal for the corresponding sum of pressure head, velocity head, and height from the datum at points A and C respectively. So we can write PA upon rho g plus VA square upon 2g plus height of point A from the datum equal to PC upon rho g plus VC square upon 2g plus HC. Of course, this velocity that we have written here, this is also at point B, but we already wrote these two velocities are equal to each other. So it is actually velocity at point B. We will find VC and that will be equal to VP. So PA and PC both are equal. We already wrote it here. That is the atmospheric pressure, because both the points are open to atmosphere. So these two can be subtracted out from both the sides. HC, if we consider the datum here at the top of the mold, then HC has to be 0. HA is given, which is the filling height, 20 centimeters. Also, VA is 0 because it is the starting point. The metal starts to fall from point A. So initial velocity of that metal at point A is 0. This is also 0. Simply we will have VC equal to HA into 2G, and taking root we have under root 2G into HA. This will be equal to under root 2 into 9.81 into 20. Now here units are not matching because 9.81 is in meter per second square and 20 is in centimeter. So we will have to convert either of them. If we convert this to centimeter per second square, we will have 981 into 2 into 20 and then square root of it. So taking that, we have the answer of VC as 198.04 centimeter per second square. Putting this value here, we have TF is equal to 18,000 centimeter cube divided by 198.04 into area at point B. Cross-sectional area at point B will be nothing but pi by 4 into the diameter of that pipe square, which is given to be 2 centimeters. So 2 square. This turns out to be 28.2 29, and the unit will be of course seconds because we have taken the velocity in centimeter per second. Let's go back and fill in this answer, 28.29. The time taken to fill up the mold cavity is 28.29 seconds. To learn about metal casting in detail, you can refer to the NPTEL video Design of Gating System 2. It's from the course Metal Casting. The course is taught by Professor D. Benny Karunakar. He is from Department of Mechanical and Industrial Engineering of IIT Roorkee. I hope this solution will help you clear your doubt. Thank you.